Well, let's look a little more carefully at the properties of logarithms. The three properties we're going to look at have a direct connection to the properties of exponents because logarithms are exponents. The product property relates to the fact that if we have b raised to the x power times b raised to the y power, we can add those exponents. So there's a connection between multiplication and addition. For logarithms, the connection is multiplication inside the argument is related to addition of two separate logarithms with the arguments, with those factors as arguments. There's a relationship that says b to the x divided by b to the y equals b to the x minus y. So again, there's a connection between division and subtraction, and we see that in logarithms by the following. The difference of two logarithms, log base b of m minus log base b of n, relates to the logarithm of those two things divided. So log base b of m over n can be rewritten as the subtraction of two logarithms. And the third property involves powers. Recall that b to the x raised to the y power equals b to the x times y, and we see a related relationship in logarithms, log base b of m to the p. So if I have something raised to a power inside a logarithm, that can be rewritten as p times the logarithm of the base. So it's really important to practice and develop your intuition of these logarithm rules, of these logarithm properties, because you can be tempted to do things that aren't allowed. And so it's really important to practice and develop your intuition of what we can do so that you don't stumble and do things that you're not allowed to do with logarithms. So let's look at some initial examples, and then I'm going to ask you to practice some others. So the two things can basically be summed up as expanding. If we have a single logarithm, we can expand it sometimes into the sum or difference of logarithms, and contracting. So we can expand a logarithm if the argument is a product or a quotient. So if things are multiplied or divided inside the logarithm, we can expand it. We can rewrite this as log base 3 of 9 plus log base 3 of x using the product rule. But of course, log base 3 of 9 we know is just 2 because 3 to the second power equals 9. And so we can rewrite that in a simpler way. And another thing I'll just point out, I wrote the x here without parentheses. Parentheses are clarifying, and sometimes we can include them, but if it's a simple argument, just like a single variable or something very simple, we sometimes don't. For just kind of historic reasons, the notation developed that we don't do that. So up next we have the quotient, 8 divided by 5. I can rewrite that as the difference of two logarithms. So log base 4 of 8 minus log base 4 of 5. So 4 and 5 aren't related very well. 4 and 8 are. To simplify that expression a little bit more, let me rewrite the 8 as 2 to the third power. So this is the same as log base 4 of 2 to the third power minus log base 4 of 5. And now I can use the exponent rule to bring that 3 to the front of the expression and write this as 3 times log base 4 of 2. And of course, we still have minus log base 4 of 5. But some of you may recognize that log base 4 of 2 is 1/2 because 4 to the 1/2 power equals 2. And so I can rewrite this as 3 times 1/2, or 3/2, minus log base 4 of 5. And so that's sort of the simplest final expression that we can get rewriting that. And so when I say simple, I mean it's simple in the sense that the argument has now become simpler. We started with 8 over 5, and now we just have 5. And so we've created a simpler number. It might not feel a lot simpler, but it's simpler in that sense. Our next example, we can use the power rule to bring that 7 to the front and turn this into 7 times log base 5 of t. And I can do that because everything inside the argument was raised to that 7th power. In the next example I want to look at, that's not the case, right? So only the variable t is raised to this 7th power. And so what we need to do is deal with the product first. So this is, again, something important to develop as you practice. Recognize that I can't use the power rule initially because bringing 7 to the front would put a 7 kind of in front of the 10, and that doesn't work. What I need to do is the product rule first. I can rewrite this as log base 5 of 10 plus log base 5 of t to the 7th. And now we can use the power rule to bring that 7 to the front, and it will just apply to the second logarithm, 7 times log base 5 of t, and it doesn't multiply with that first logarithm. So that's why we had to do the product rule first, so that everything that was left behind inside the parentheses that I could add there, everything left behind is now raised to the 7th power. So the other side of things is that we can contract logarithms and make them simpler. With the product rule, if I have the sum of two logarithms that have the same base, I can combine them as a single logarithm. This would be log base 3 of 70. I can combine them as a single logarithm by multiplying the arguments, and I can combine the difference of two logarithms into a single logarithm by dividing. 42 divided by 7 is, of course, 6. And again, the bases match, so that's why I'm allowed to do this. They're both base A. The last expression, I want to slow down a little bit and look at this carefully. Notice, what do we have in the argument? It's a sum, not a product. So one thing I wanted to point out with this example is that we cannot simplify the sum inside the argument of a logarithm. So again, this is something to build your intuition about. We can simplify the sum of two logarithms that have the same base, but I can't simplify a sum that's inside the logarithm. What I can do with this expression, because there's this factor of 2 in front, I can turn that factor into an exponent on the inside and rewrite this expression as log base 4 of x plus 3 squared. And now I can do some algebra inside the argument. So I can actually, multiply this out. And so, maybe just for fun, let's do that. So log base 4 of x squared plus 6x plus 9 is what that would become. Whether that's simpler or not, I don't know. That's a point that could be argued, perhaps. But again, I have a sum inside the logarithm, and so I can't break that into separate logarithms, right? I can split a product into separate logarithms, not a sum that's inside the logarithm. So this is why we need to practice. This is why we need to develop our intuition, because there's some subtlety in how we can apply these logarithmic properties. Well, one more example that I'd like to look at is simplifying this combine expression. I want to combine that into a single logarithm, lots of different stuff going on here. And so let's get to work. The first thing to notice, again, is that when I'm contracting, I want to start with the power rule. So if there's any constants being multiplied by a logarithm, let's pull those in first. The second thing to point out is that the base needs to match. So this is a base 7 logarithm, And so that's important. I can't contract different types of logarithms without, having the bases match. So I can rewrite this as log base 7 of a cubed, bringing in that exponent, and log base 7 of b to the 1/2. And there's not much to do here. I'll just keep that as minus log base 7 of c. But this 2 sitting at the end is a little odd. But you might realize that 2 is the same as 2 times 1. And 2 times 1 is the same as 2 times log base 7 of 7, because log base 7 of 7 is equal to 1. 7 to the first power equals 7. So I can rewrite that 2 as 2 times log base 7 of 7. And that'll allow us to combine things a little bit more in the next step. So let's see what we can do next. Next, I want to combine these first two using the product rule. This will become log base 7 of a cubed. And now b to the 1/2, let me write that as the square root of b, because that's sort of a nice form for that to take. I'm going to leave the next thing alone, log base 7 of c. And I'm going to change this. I'm going to bring that 2 and turn it into an exponent and write it as log base 7 of 49, because 7 to the second power, 7 squared, is 49. And now I can combine these two logarithms using the quotient rule. So I get log base 7 of a cubed times the square root of b over c. We still have plus log base 7 of 49. And we can combine these now using the product rule. And so we get log base 7, a single logarithm. The product rule is going to put the 49 up in the numerator. 49 times a cubed times the square root of b, or b to the 1/2, over c. And there we have it. We've combined that complicated pile of terms, the sum and difference of all these logarithms, into a single logarithm. And just a couple things to summarize here. So what we can do with logarithms, the two main simplification steps, is we can expand a logarithm if it has a product, a quotient, or something raised to an exponent. If everything is just a pile of factors, basically if there's a monomial inside a logarithm, we can expand it. So let me actually add that here. If it's a monomial, we can expand it. If the argument is a, oh my goodness, I can't spell. If the argument is a monomial. And the second thing we can do is we can contract if we have a sum or a difference of logarithms, we can contract them into a single logarithm as long as the bases match, right? So if the bases of the logarithms match. Which leads me to the last thing I wanted to mention in this video is the change of base formula. We've talked previously about the change of base formula. We can now justify it. And let me actually, maybe I'll separate that into a separate video, the justification of the change of base formula.